This week I'm going to be talking about setting up role-based permissioning in a Polymer application with a Firebase backend. This video is going to expand on some topics that we covered in previous videos, specifically the video on app routing as well as the video on setting up a Polymer application with Firebase. I want to start things off a little bit different this week by first going through a demo of the functionality as we want it to happen in the app when everything's done. Specifically, we're going to take a look at how the Firebase database updates in real time as we're performing our actions. Here's the Firebase console. It's already pre-populated with some data on my user that I've been using for testing and that we're going to be using for the demos. The functionality that we're going to be covering today is really broken into three parts. The first part is a database trigger that monitors changes to a user's roles and will update their custom claim. A custom claim in Firebase is a way to associate data with a user's JWT so that it can be parsed and used not just in the database rules but also in the UI. We'll be using this to associate roles to a user that we can then consume. The side effect of these updates is actually the metadata changing. Since JWTs aren't automatically updated whenever there's a change made to them, we need some notifier from the database to let us know that we need to fetch a new token. That's what we're using the metadata for here. Our role structure today is going to be able to support both nested and multiple dependencies under that nesting or flat structures with just a true value. The second piece of our functionality is that whenever a new user registers, we need to create an entry with a default role for them. The final part is going to be consuming the roles that we created in both the UI as well as database permissioning. Now that we've seen how we want the database to update and interact with our data, we're going to go ahead and start taking a look at our database rules. They're going to be very simple and straightforward, so I want to get them out of the way first. We have three rules that are currently assigned to our database. The first one, the rule associated with metadata, allows that only users that are currently authenticated as that user ID can read the data and no one can write to it. Setting write to false is a little misleading because it doesn't actually prevent every source from editing it. The only source that'll be able to edit this data whenever the write is set to false is the admin SDK. Since our cloud functions rely on the admin SDK, we'll be able to modify the metadata from there, whereas nowhere else will be able to modify it anywhere in our application. The next block I want to look at is users. We're preventing both read and write here, which means that the only way to view or modify this data is through the console or the admin SDK. This is going to prevent anyone from being able to modify their own roles or modify another user's roles. The post section is the last one I want to take a look at. We have it open to where anyone can read posts, but in order to write to a post, you have to have the author role associated with your auth token. Next, I want to take a look at the three files that we're using to build our cloud functions. The index.js, which is going to be used to register our functions, the register.js, which is used for a new user registering, and the roles.js file, which is going to be used for monitoring changes to the user's roles and assigning those roles to the JWT. We'll take a look at the index.js first. The code for it is quite simple. We just need to import the Firebase admin logic and the Firebase functions logic, then we can initialize our app. Once the app is initialized, we need to export all of our modules that are going to be used through the Firebase logic. Instead of writing all my logic directly in index.js, I chose to segment my logic based on its functionality in separate files. In order to expose the cloud functions I've created in the other files, I need to import them here using the require syntax and then combine all of their exports into a single exposed one that will be provided to Firebase in order to do registration. For this, I'm using object.assign to collapse all of them into a single exports object that I then expose globally using the exports property. Now that we've handled registering our functions in Firebase, let's take a look at the registration.js file. Here we're going to watch for creation of a new user, and then we're going to add an entry to our user's object that contains the default roles for a user. To do this, we need to create a new cloud function. We're going to call this cloud function process_signup. We use the Firebase functions auth.user.onCreate to watch for user creation events. When a new user is created, we get an event with data on it that is the user reference. Next, we can use the admin SDK to set up a database reference to our user's object. It's pointing directly to that user ID that we were given. Last, we'll call set on that database reference to push data to our new user entry. Specifically, we're going to be passing it a roles object with the default role of user. Cloud functions have to return either a value or a promise in order for Firebase to know when that function is done processing. In this case, the database reference.set returns a promise, so we're good here by just returning that value. Now that our new user object is being created in the database, we can add triggers to watch for the roles to be updated and set those in the custom claims. To do that, we're going to take a look at our roles.js file now. We're going to start by setting up our function name, which is setUserRoles, and attaching it to exports. Now we need to bind it to a trigger. In this case, we're going to use the function's database reference for users/user_id/roles. We then want to watch for the onWrite event, which is going to be covering all of our cases for adding, deleting, and updating. We can get the roles data by grabbing event.data.val, and we can grab the user ID by looking at the event.params.userid. The params property is added for all wildcards that are in your reference. Next, we'll create our custom claims object. By default, custom claims are merged directly with your JWT, but we want all of our roles to be nested under a roles property on the JWT, so we'll assign it as such. Now we need to assign our custom claims. So we're going to use the admin SDK on the auth segment again, and we're going to call set custom user claims and provide it the custom claims and the user ID that we want to assign. This is a promise, so we'll go ahead and return this promise so that our Firebase function resolves properly. Once our custom claims are done, we need to make sure that we update our database reference for metadata for that user. To do this, we'll create another database reference for metadata/user ID. And then we'll use our set function to add an object with refresh time to the current time. We'll go ahead and return this in the promise chain so that the Firebase function waits for the database to be updated before it considers the function done. Now that we've got our database rules set up and our cloud functions configured, we're going to go ahead and take a look at how to handle these roles in the UI. To do this, I'm going to be creating a new element I'm going to call am-roles in order to monitor changes to these elements and relate them back to the UI for us. First, let's take a look at our template. We'll import Firebase auth to monitor the user object as well as the signed in state. We'll also need to import the Firebase document so that we can grab a reference to this user's metadata and take a look at the refresh time property for monitoring changes whenever the JWT is updated. Next, we'll set up some properties to make dealing with this object a little bit easier. The first property we'll take a look at is active. Its purpose is for providing us a nice little boolean letting the user know when the role that they're looking for is active or not. Next, we'll provide them a way to tell us what role they're interested in through the role property. Next, we'll need to track the roles that are associated with the user's current JWT. This will set to read-only and notifies that only this element can change it, but any element above it can access it. Last, we'll go ahead and send the signed in property and the user property directly through to the Firebase auth element internally. This will prevent some of the cases where we need to have a second instance of Firebase auth. It also lets us monitor changes to the signed in property so we can do force refreshes. Our primary logic is associated with the parseRoles method. This method takes in a user object as well as a config object that uses force refresh defaulted to false. We'll start by debouncing at a microtask level to prevent this function from running multiple times when it only needs to run once. Next, in our debounce function, we'll grab our user reference and call getIDToken. GetIDToken is provided to us from the Firebase SDK and takes one property. That property is a boolean called force refresh. When that boolean is set to true, it will replace the local JWT with a new one from the server. This is what we're using to update whenever our custom claims object updates. The getIDToken method returns a promise with the ID token. We're then going to take the token that's provided back to us from that method, and we're going to parse it using a method I'll show you next called parseJWT. And then we're going to assign the roles property off of that object to the roles property locally on this element. Here's the parseJWT method that I wrote. I'm not going to go into too much detail about the logic associated with it as it's pretty standard. You can find it online in quite a few different places. I just wanted to briefly show it here for completeness as well as talk about how I bound it to the global scope window.am. While I don't plan on using the parseJWT anywhere aside from this element, I figured it's nice to have it in a global scope just in case I do need to use it elsewhere. But to be safe, I went ahead and set it on a namespace called am to prevent any conflicts with the naming. Last, we're going to take a look at what we need to do in order to refresh the token whenever the database updates. As we saw previously on the Firebase documents reference, we have an event listener called refresh time updated. This is called anytime the data changes coming from the database. Within here, we need to check to see if our value is a number, which means that we actually have a database entry and we don't have a logged out user, for example. Then we can call the parseRoles. We're going to use this in conjunction with a private property called force refresh. After any time that we call parseRoles, we need to then set force refresh to true so the next time it gets called, we're doing a force refresh because that means the database updated since the last time we checked the JWT. If we don't have a value set to number, it means that we either have a logged out user or they don't have a reference in the metadata. In that case, we need to go ahead and set roles to an empty object. Last, we're going to watch for changes to the signed in property and set force refresh to not signed in. What this does is it'll set our force refresh to false the first time we sign in, and then if the parse roles is called, it'll set it back to true so that if multiple calls are made between login logout sessions, we'll get new force refresh, so it'll force updates to the JWT. Now that we've got our AM roles element, I'm going to show you an example of implementing it into the application. I'll go into more details about building out this blog page on a later video, but for now let's focus on the author role. We're going to set up an instance of our AM roles element and provide it the author role so that we can monitor changes to that for the user. Whenever the user's roles update, the active property will get set to true or false based on what that user's roles are and if they contain the author role or not. As roles is an object, you can always bind directly to that using nested properties as well. In this case, I'm also needing access to the user object later, so I'm going to go ahead and grab that off of the AM roles element as well. Below, you can see my every helper function, where I only show the create section if both the create property are toggled true and the author role is set on the user. This allows an easy way to toggle segments of your app on and off based on roles. Unfortunately, it's easy to get around this kind of permissioning by just toggling on your inspector and changing the properties directly, which is why we went ahead and set up the database rules to also rely on those same roles being provided at the database level. This means that even if they go in and toggle a section of your UI on that would otherwise be blocked for them, they can't interact with it since the database would also reject their actions. That wraps up my video for the week on role-based permissioning in a Polymer application using Firebase database. I hope you guys enjoyed it and it's useful for some of you. I'll include links to my source code in the description of the video as well. If you have any questions, feel free to post them here in the comments, or you can find me on the Polymer Slack channel at @Murdoch.